Mars is red because it is rusting. You probably already knew that. But that answer only opens a much stranger question. Rust requires iron, oxygen, and water. Mars has the iron, but its atmosphere is 95% carbon dioxide with almost no free oxygen, and its surface has been bone dry for billions of years. So how did an entire planet rust? The answer is not simple. It is a 4 billion-year-old story involving oceans that no longer exist, a magnetic shield that failed, ultraviolet radiation that tears molecules apart, and dust storms the size of continents. The red color of Mars is not decoration, it is a scar. Welcome to Drowsy Inquirer. Today we are going to peel back that scar, layer by layer, and find out what happened to a planet that was once blue. Look at Mars through a telescope, and you see a disk of orange and red and brown. The color is remarkably uniform. Almost every surface feature, every mountain, every canyon, every crater floor is covered in the same fine dust. This dust coats everything like a planetary layer of powder. The dust is extraordinarily fine. Individual grains are just a few micrometers across, smaller than a human red blood cell. The texture is closer to flour or talcum powder than to sand. It clings to everything. It infiltrates everything. It is the defining substance of the Martian surface. And it is not just on the ground. Mars dust hangs in the atmosphere permanently. The sky on Mars is not blue. It is butterscotch, a pinkish amber haze created by countless trillions of iron oxide particles suspended in the thin air. On a scattering sunlight in every direction, the red comes from iron oxide, specifically minerals called hematite and goethite. On Earth, we call this rust. The chemistry is simple. Iron plus oxygen equals iron oxide. The same reaction that turns a steel nail brown in the rain turned an entire planet red. But on Earth, rust needs two things. It needs oxygen, which makes up 21% of our atmosphere, and it needs water, either liquid or as humidity in the air. Both are abundant on Earth. Both are essentially absent on Mars today. The Martian atmosphere is 95% carbon dioxide. Free oxygen makes up only about 1/10 of 1%. The atmospheric pressure at the surface is less than 1% of Earth's. Liquid water cannot exist on the surface under these conditions. It would either freeze or boil away almost instantly. So the question stands, if there is no oxygen and no water on Mars today, how did the iron in the Martian soil become oxidized? How did an entire planet rust? The answer begins 4 billion years ago, when Mars was a completely different world. 3.5 to 4 billion years ago, Mars had a thick atmosphere. The surface was warm enough for liquid water. Rivers flowed across the terrain, carving channels that are still visible today from orbit. Lakes filled craters, deltas formed where rivers met standing water. Mars may have had a vast ocean covering much of its northern hemisphere. We know this because the evidence is carved into the surface. The Mars rovers, Curiosity and Perseverance, have photographed dried riverbeds, layered sedimentary rocks, and mineral deposits that can only form in the presence of liquid water. Orbital images show branching channel networks, delta formations, and ancient shorelines. Mars was wet, and where there was water, there was rust. The Martian surface is composed primarily of basaltic rock, volcanic rock rich in iron-bearing minerals like olivine and pyroxene. When liquid water came into contact with these rocks, it dissolved the iron. The dissolved iron reacted with whatever oxygen was available, forming iron oxide minerals. The rock rusted from the outside in. This process happened everywhere water touched rock, across every riverbed, every lake shore, every flooded crater. Millions of years of water in contact with iron-rich basalt, slowly converting dark gray rock into red iron oxide. The planet was rusting on a continental scale. But water alone does not explain everything. Recent research has revealed another mechanism, one that continues to this day even though the water is gone. Mars has no global magnetic field. Earth's magnetic field acts as a shield, deflecting charged particles from the sun and protecting the atmosphere from being stripped away. Mars lost its magnetic field approximately 4 billion years ago when its internal dynamo shut down. Without that shield, the Martian surface is exposed to the full force of solar ultraviolet radiation. This ultraviolet radiation is powerful enough to break apart molecules. It splits water molecules into hydrogen and oxygen. It splits carbon dioxide into carbon monoxide and reactive oxygen. These freed oxygen atoms and reactive oxygen species are chemically aggressive. When they attack the iron in the surface rocks directly, oxidizing it without the need for liquid water. This means Mars is still rusting right now, not through water, which is gone, but through photochemistry. The sun's ultraviolet light is continuously producing reactive oxygen on the Martian surface, and that oxygen is continuously converting iron minerals into iron oxide. The process is slow, but it has been running for billions of years. And then there are the dust storms. Mars produces the most spectacular dust storms in the solar system. They can begin as small regional events and grow within days to encircle the entire planet. A global dust storm on Mars can last for weeks, reducing visibility to near zero everywhere on the surface simultaneously. These storms pick up the fine oxidized dust and transport it across the entire planet. The dust that formed in one region is carried thousands of kilometers and deposited everywhere. The storms act as a planetary mixing system, spreading the red color uniformly across the surface, like a brush painting the entire world in rust. When the storms subside, the dust settles. Every surface is freshly coated. Every rock, every slope, every crater wall receives a new layer of fine iron oxide powder. The planet repaints itself with every major storm. Mars is so dusty because it has been grinding its own rocks to powder for billions of years. The atmosphere is thin, but wind still blows. Martian wind speeds can exceed 100 kilometers per hour during storms. Over billions of years, this wind has eroded rock surfaces, sandblasting them grain by grain, reducing boulders to cobbles, cobbles to pebbles, pebbles to sand, sand to dust. And because Mars' gravity is only 38% of Earth's, once dust gets into the atmosphere, it stays there much longer. Particles that would settle in hours on Earth can remain suspended for weeks or months on Mars. The planet produces dust and then holds on to it, building an ever thicker layer of fine iron oxide powder over its entire surface. All of this traces back to one catastrophic event: the death of the Martian magnetic field. Early in its history, Mars had a global magnetic field generated by a dynamo in its liquid iron core, just like Earth has today. This field shielded the atmosphere from the solar wind, the stream of charged particles continuously flowing outward from the sun. With its shield in place, Mars could hold on to its thick atmosphere and its liquid water. But Mars is smaller than Earth. Its interior cooled faster. Approximately 4 billion years ago, the liquid iron core solidified enough that the dynamo stopped. The magnetic field collapsed, and without it, Mars was defenseless. The solar wind began stripping the atmosphere molecule by molecule. Over hundreds of millions of years, the thick protective blanket of gas was eroded into the thin remnant that exists today. As the atmosphere thinned, the surface pressure dropped. Liquid water became unstable. The oceans evaporated. The rivers dried up. The lakes vanished. Mars went from a warm, wet world with rivers and oceans to a cold, dry desert with almost no atmosphere. And it happened because a magnetic field failed. One invisible shield gone, and an entire planet died. You might wonder why Earth has not suffered the same fate. Earth has plenty of iron in its rocks. Our Earth has water and oxygen. Why is Earth not red? The answer is that Earth has defenses Mars lost. Earth's magnetic field is strong and active, powered by a dynamo in its liquid iron core that has been running for billions of years and shows no sign of stopping. This field deflects the solar wind, protecting the atmosphere from erosion. Earth also has active geology. Plate tectonics continuously recycles the surface, bearing oxidized rocks and exposing fresh material. Weathering and erosion move iron oxide into rivers, which carry it to the ocean, where it is deposited as sediment and eventually subducted back into the mantle. The rust is cleaned up, recycled, hidden, and Earth has life. Vegetation covers much of the land surface, hiding the rock beneath leaves and roots and soil. Photosynthesis continuously replenishes the oxygen supply. The biosphere is a living shield that Mars never had, or if it did, lost long ago. Mars had none of these defenses. No magnetic field to protect the atmosphere. No plate tectonics to recycle the surface. No life to cover the rock and replenish the air. Mars was left exposed, and the iron in its rocks oxidized without resistance, without repair, without renewal. The entire planet turned red. When you look at Mars through a telescope, or in a photograph, or as a faint red point of light in the evening sky, you are not looking at a color. You are looking at a chemical reaction. You are looking at the visible evidence of a planet that lost its magnetic field, lost its atmosphere, lost its water, and has been slowly rusting in the sun for 4 billion years. Every grain of red dust on Mars is a fossil, not of life, but of water. Every particle of iron oxide was once part of a rock that was touched by liquid water or bombarded by ultraviolet radiation that freed oxygen from molecules in the air. Every grain is a record of a chemical event that happened billions of years ago, preserved in a mineral that will last for billions more. The red color of Mars is not a feature. It is a wound. It is the visible mark of everything that was lost. A thick atmosphere, gone. Liquid water, gone. A magnetic shield, gone. What remains is iron oxide, the simplest possible testimony that once, long ago, this dry, frozen world was something else entirely. And Mars cannot heal. It has no mechanism for renewal. No magnetic field will restart. No atmosphere will rebuild. No oceans will return. The rust will remain, and it will deepen, grain by grain, storm by storm, for as long as the sun shines on its surface. Next time you see Mars in the night sky, a faint red dot among the stars, you will know what that color means. It is not paint. It is not pigment. It is the death certificate of a planet's atmosphere, written in iron oxide, visible from 100 million kilometers away. 4 billion years of loss, compressed into a color, carried on every grain of dust, scattered across every surface by storms that circle the globe. That is why Mars is red, not because it is painted, because it is wounded, and wounds that old do not heal. Rest with that tonight. Somewhere above you, if the sky is clear, a red dot is shining. It has been shining that color for longer than life has existed on Earth. It will keep shining that color long after you fall asleep. Good night.